Hi folks, welcome to part 2 of the vector tutorial. We're looking at the PhET simulations vector addition. We're in the fourth module, equations, and this is what it looks like when you first bring it up. Note I have clicked on the C vector and it's showing me up here the magnitude, angle, x component and y component of C. In the second bar here, I've got a plus b equals C, a minus b equals C, and a plus b plus C equals 0, or a plus b equals negative C. So clearly, if we just split between these two, that's C, that's negative C. And we can make multiples of our vectors. We have our base vectors are over here. And what I'm going to do is, okay, I'm going to make A so that it's not vertical like that. We could also show our vectors, so our base vectors, and then as we add and subtract these, the C, which is the equation here, right, changes. So let's go back to A plus B equals C. And I'm just going to bring C over here. Now notice that when I'm moving my vector around, my magnitude doesn't change, my angle doesn't change, and my x and y components do not change. And that's true for any vector. Likewise, I can grab the origin and move it wherever I want, in effect, moving all the vectors at once. So again, just moving them around or moving my coordinate system doesn't change the vectors. Over here, we can look at the x and y components of our vectors. There's 3 different styles. This one, I think, is quite useful in that we see explicitly that, for instance, C is the sum of Cx and Cy. But it's also very useful, I think, to have the projections on the axes like this. So if we take A and we put B, so add B, and then if we put C where it belongs, we can see that if we just add our vertical components of A and B, well, that equals our vertical component of C. Likewise, if we add our horizontal components of A and B, that's equal to our horizontal component, our x component, of vector C. Now note that we can take B and put it down here, and take down here, and then take A and put it up here. All right, and so now we've got, instead of A plus B, we have B plus A. Well, it's exactly the same vector. All we've done is move our vectors around. But we can see that, the vertical component of B plus the vertical component of A is the vertical component of C. And the horizontal component of B plus horizontal component of A gives us our horizontal component of C. Let's turn the components off for a minute. Let's look at the difference between the sum of vectors and the difference of vectors. Now you see, when we have sum of vectors, we add our vectors tip to tail, okay? So C is the vector that if we add B, we go along B and then go along A. That's the same vector we get if we would go along C. Now A minus B is, if you start with B and you go along C, the final vector is A. So if you go along B and then C, we get A. So essentially, we can rearrange this equation as A equals C plus B. A equals C plus B, or B plus C. So again, this is the sum of my vectors. And yes, it kind of sort of looks interesting to put it like this, but it makes sense because these are all free together, okay? And then you add them like that. So note that if you put tip to tip, we get our difference. If we put tail to tail, then that's our difference. But if we put tip to tail, that's our sum. That's it for now. Oh, there's a question. So in order to get credit for the tutorials, what I want you to do is email me and tell me what were the 4 locations that we visited in San Francisco. If there's any questions, please let me know. I would be happy to have a Zoom session with anybody. Thank you and good luck.